Alright, next we're going to find the empirical and molecular formulas. You're going to obviously, the first thing that you find is the empirical formula, and then you use the molar mass that you're given to find the molecular formula. Sometimes your empirical and your molecular formula might be the same, actually. Sometimes they will, and there's no reason to just like check that or be scared about that, because that can happen. But sometimes it doesn't. So sometimes you will have different formulas. It just depends on the molar mass that you're given and all that other stuff. So that's all it depends on. So we are given, I'm going to do it on my bed because like my back is hurting sitting on my throne, because my drawers do not go all the way in, which is very annoying. So when you sit with your back against them, it hurts like significantly bad. So yeah, all right. Here we go. So you are given the percentages. Let me pull it up. Oh, dang it! 1 second. So you're obviously given these percentages, and don't get freaked out that they're percentages, because in every case when you have these, you just use them as if they were grams. So just pretend that the percentage signs are grams. So you got 62.27. Let's do this in all different colors. So we got 62.27 grams. We're doing a gram to mole conversion. Why are we doing a gram to mole conversion? Because when you get the moles, you gotta divide by the whichever out of the 3 elements has the lowest moles, and then you get a number, and you multiply. You put those numbers for each element that you're given. So if you get 3 for C, you get C3, and you get 2 for H, you get C3H2. Those are your subscripts. The numbers that you end up getting are your subscripts. So you're going to take that, we're going to make it into moles. So we know that a gram to mole conversion, that's an easy one, right? So in order to cross out the grams that we are given, we have to use the molar mass, which is 12.01. Okay. And we're going to put 1 mole because, that's what we're finding, right? So I'm not going to figure that out right now because I'm just going to set up each problem. 7.19 grams of H over 1. And the molar mass is 1.008 grams below 1 mole. Then we got 28.54 grams of O. We know the molar mass is 16 grams. So basically you're just taking what's given with the percentages, and you're taking that and you're dividing it by the molar mass of that element to get moles in this conversion, obviously. Now we have to do the math. So we got 62.27 divided by 12.01, which gives you 5.18484. 484. Okay. In this case, you want to write out as many decimal places as you possibly can, because you're not entirely sure if another element's moles is going to have a close number. Because if they have close numbers, they're both 0.5153 because you rounded, how are you supposed to know which one's less? So you got to write as many as you can. And sometimes you have to go back because you didn't write that many numbers that you were supposed to. So the next one is 7.1329. It looks like we're going to be okay. 4 divided by 16. Yeah, looks like we're going to be okay. 3. So you're going to divide by the lowest number, which we can all determine that it is 1.783, so O's. 783 divided by 1.783 to get the subscripts for the empirical formula. This is to find the empirical formula. We have to find the empirical formula first, and then we find the molecular formula later. So we're going to get the numbers for each subscript of these. So 0.14 divided by 0.783. 2.9 4 basically. Alright, so when you do these, obviously this one's going to round to 3. So you're going to use 3 as a subscript, 4 as a subscript for that one, and 1 as a subscript for that one. So you're going to your compound is going to be C3H4 and 0. I mean not 0, O. Duh. Because you have C here, H here, and O here. And that's your compound. Alright, so now we have our empirical formula, which we determined was C3H40. I mean not 0. Why do I keep saying 0? It's O. C3H4O. Alright, so now to find the molecular formula, we have to take the subscripts that we are given, and we have to multiply each of them by their molar mass. So basically what you're just doing is you're just going to take the number, the subscript, and you're going to multiply it by the molar mass. So you have 3 for C. I'm just going to write 3C so you know what I'm doing for which element. So you got 3C times 12.01. Then you got 4H times the molar mass, which is 1.008. And you got 1 oxygen for 16 grams, which is the molar mass. Why do this? Basically, you're finding the molar mass of the whole compound. That's all you're doing. Just find the whole I'm just breaking it down. Just find the molar mass of the whole compound, which if you did it, I'm just doing it in separate cases just to give myself, it's just, I can actually see what I'm doing and you can see what I'm doing. So these are the molar masses for each element. Now what we have to do is we have to add them together to get the whole molar mass of the whole compound. You don't have to do this extra step. You can just figure it all out, but I feel like doing it. So you get 56.062. That's the whole molar mass of empirical formula, right? Alright, so you got that, right? Now what you're going to do is you are going to take the molar mass that you're given. So if you look at that sheet that you're given a specific molar mass. You have to use it. It's not just there for no reason. That is there for a reason. It's the experimental. So what you're going to do is you're going to take that experimental mass and you're going to do 168.19. That's it. It's supposed to be a 9. It looks like a G. 19 over the whole molar mass of the compound over 56.062 to get a number. It's not going to be that big of a number, by the way. It's going to be a small one. Usually. You get it around 3. It's going to be like 3.0001. It's 3. Okay. So now you're going to take that 3 and you're going to multiply it by the empirical formula. So you're going to go 3C3H40. So you're going to take 3 times 3 is 9. 3 times 4 is 12. 3 times 1 is 3. This right here is your molecular formula. So now the thing is though, if you divide each of these numbers by 3, you get back to the empirical formula.